I've been at this for a long time. In fact, the whole concept of wearable display technology probably goes back as much as 75 years, if you look. And for me, in 1991, I jumped into the fray to make wearable virtual reality gaming systems for the PC marketplace. At the time, Jaron Lanier was out telling everybody about how great the world's going to be virtualized. Glasses on and you're going to step inside of this virtual space and it's going to just create this almost acid tripping thing. And quite frankly, even I was kind of into that concept. So I started a company called Forte Technologies, and we built this football-sized helmet that you put on. It plugged into an ISA bus on a computer system that barely had a graphics adapter in it. And in our first quarter of shipping, we sold $5 million worth of these gizmos. So back in 1991, that wasn't bad, and it was an exciting start, and there was so much hype going on around the whole thing. It was like, wahoo, this is the beginnings of the most amazing experiences for people. And the reality soon hit, which is often the case in the head-mounted display industry, that the experience isn't good enough. The resolutions aren't high enough. The graphics performance isn't good enough. The fields of view aren't good enough. So that company, under my helm, struggled till 1997, and I said, look, I'm going to reorg this thing and start over, but when we do it this time, we're going to focus on the defense space first. We're going to work on trying to fix the technology problems, and we're going to get customers for the products that make sense, that are derivative things out of this whole near-eye display business and wearable display tech. So Forte Technologies started in 1997. Focused on the defense. We built night vision display engine electronics that go on the backside of thermal night vision systems. We became one of the #1 suppliers to DRS and Raytheon and the like in that space. At the same time, the government came to us and said, you know, guys, we got these people in the field carrying 150 pounds worth of gear, and a big piece of it is the computer systems that they're carrying and the display systems that are associated with them. And besides that, when you open these computers up, they light up like a Christmas tree during the day. Can Vuzix help us try to solve that problem? So we started working with DARPA, the Air Force Research Labs, on advanced next-generation optics, et cetera, to try to shrink that technology down. And hey, guess what? That's the same kind of technology that fits really well with where the wearable display space is going today. So in 2004, we shipped our first consumer wearable display product again. These things look like they came off the Starship Enterprise. Wasn't a football helmet, but it was a Three Musketeers bar now that you put on and you wore in front of you, and it gave you this modest field of view experience, but it was a private video viewing experience that worked reasonably well with the coming products that were mobile-oriented video players. Worldwide operations, we have product lines for immersive viewing, virtual reality systems, augmented reality systems, and they are all still based upon technology today that's kind of old. Refractive, reflective optics, et cetera. And so you end up with these big, bulky kinds of devices. But if you take the technology that we've been developing on the defense side and you put it together, we are on the cusp of changing all of that, of coming out with the technology that the industry that's coming around really needs to have to make these things look like fashion statements and like regular glasses. So a lot's changed since I first started this business. Everything's gone mobile. The internet connects people 24/7. I mean, these are all things that you all know, but I thought it wouldn't hurt to remind you. Processing power, the size of the silicon. I mean, you carry around today something that used to be like a Cray computer back in the old days. I mean, it's amazing the processing power that you have in the palm of your hand, and it's always connected. These changes are so profound that they're taking the PC industry to its knees. And the cell phone, in my opinion, is the thing that's driving the whole wearable technology drive. It's the thing that's making it happen, and it's actually tearing apart a bunch of other industries in the process. Excuse me. So wearable tech has evolved from, you know, probably the first wristwatch that came out. You probably all remember the Casio watches that had a computer built into them, so you could, computer. I say that a little flippantly. It was a calculator. But it was cool. It was a wearable device. You had it on your wrist, and it was nowhere near a pebble, but it was still a pretty cool device. Because the cell phone has come along now and it is wirelessly connected, all of a sudden these devices are doing a whole lot more than standalone. They're connecting into these mobile devices like your cell phone and out to the real world. So it's opening up an amazing amount of opportunities that just didn't exist before. It's building billion-dollar industries and markets centered around the billion-plus cell phones, smartphones that ship on an annual basis. If you look at the projections, it's estimated that there'll be upwards of 500 million by 2018 wearable tech kinds of devices, whether they're wristwatches, heart rate monitors. There's many categories of devices that are coming, and of that, upwards of 100 million of them will be wearable display kinds of devices. I think ultimately, if you look far enough into the future, those numbers are going to accelerate in a big way when the technology finally becomes a fashion statement. But it's big business, and it's coming. And the wearable display part of it is probably one of the most challenging pieces of all of them to make happen well. The history, this stuff started, well, this patent was for the first wearable television set back in, excuse me, 1945. And to me, it's arguable that the most interesting piece of technology in the wearable space is, in fact, wearable displays. And it's gone through an amazingly crazy history. In the 60s, wearable 3D TV sets, Evans and Sutherland, the first wearable display system that actually allowed you even to look around inside. In the 90s, the wearable display got a computer with you, so you could suddenly, walk around like a cyborg with this big, bulky head-mounted display system and the computers and the giant battery packs. And they even tried to make that cool. They started fashion shows, tried to get the world to accept these things like they're Oakley sunglasses or something, which they clearly weren't. And then, quite frankly, just a few years ago, even, this technology is just big and bulky, and it's useful in some cases, but for the most part, we're hammers looking for a nail, a way to make these things become something, because the idea is so cool, and the things that you could do with them are so cool. But the form factors, plugged into the wall, big, bulky kinds of devices, it just never really found a place yet, except for the occasional success story in defense areas and the like. So why now? Why does it matter? The phone is being used for some amazing experiences today. It's no longer internet, text, and voice, as we all know. One of the fastest growing application categories is augmented reality. The idea is you hold your phone up, the phone looks out into the real world, the software that's running measures the real world, calculates it, modifies what you see in the real world, and then the screen that you see in the back is now an augmented version of what's in the real world. And it's delivering these fantastic experiences from travel, gaming, location-based services, e-learning. But the problem is you have to hold the phone up. And you look kind of stupid when you're in downtown New York City going like this, looking around. The fact of the matter is the user interface on a phone is just not designed to deliver those kinds of experiences. The processing power is there, the camera systems are there, but the UI just doesn't come up to speed. And if you look at the evolution of the smartphone and how it got here today, it started with that many people thought, why would I even want to use that thing? It was the size of a brick. That went to text messaging. It went to the computer system colliding into the smartphone, the addition of the internet. Today, we have the smartphone, and it is going through, because of the things that people are doing with them, yet again, more changes. Connectivity, et cetera. And the cool thing is there's a wonderful opportunity now for the wearable display systems to tie all of this together and make those user interfaces that are required much more natural. And you're going to see here, as I get a little bit further, some videos that show how this will work. But it's going to be cool, I can tell you that. Walking down the street in France, let's say, you have your glasses on, you don't read French, but all the street signs are translated to English for you. The problem is you can't do that with some of those other headsets that I showed you. I mean, just most people wouldn't put those headsets on and walk down the street, let alone the power cord that you would need to run them from. So the display, the headset technology itself needs to change. Experiences from navigation, translation, purchasing products on the street just by looking. These all are the goal, but to do it, you need wide fields of view, and you need glasses that look like a fashion statement, not these oddball-looking things that mostly are what's in the marketplace today. It's really hard to do, too. So what you do you've got a micro display, and you take this micro display and you put optics in front of it. This is just for the display piece, not to mention the rest of the technology that's required to make these things work, okay? We're focusing on display for a minute. You got this micro display, which is a display that's the size of one of my fingernails. You got these bulky optics that sit in front of it. They take the light off of the display and they bend it, put it in front of your eye, and it creates a virtual image out in space. And that sounds simple enough. But to do that and make it look like normal sunglasses is a really difficult thing to do today. The technology just doesn't do it well. So the challenge is to make these things look like regular eyeglasses, HD, smart, see-through, and aware of the world around you, all in something that's as small as a pair of glasses. It's a really tough challenge. And in my opinion, at best, we're at the early cell phone days of this industry for the wearable display marketplace. The market has been hampered by the big, bulky appearance of stuff, and this technology today, what you're seeing in the marketplace, is really more acceptable, in our opinion, in the enterprise space because it's a tool. It doesn't really matter what they look like. So there are opportunities, many of them coming, we think, in the enterprise side of the business. And when they finally goes from these things to things that look like sunglasses, it'll be like the evolution of the cell phone into the mainstream marketplace. Yes, but still, as negative as I've been talking about where the state of the art is today, it has come a long ways. You know, these are kind of joke devices, but the fact of the matter is this wearable computer system right here is an amazing tool if you could actually do that in something that was small. And there are technologies today that are coming out that allow all of the features and functions that would be in this device to be in something that you can wear. And smart glasses fit that category. They may not be, I should be careful what I say here because we're making them ourselves. They may not be the mass market yet, but every single thing that you could do with this device now can fit on something that's the size of a Bluetooth headset that you would wear from Plantronics, as an example, although theirs are much smaller than these days. These first devices from Vuzix that we came out with, announced them at the Consumer Electronics Show. As I described before, these guys are effectively a smartphone. They have everything in them but the 3G connection to the rest of the world. When you look inside of this again, it's exactly like holding your cell phone out in front of you. So you've got this personal computer screen, you've got a dual-core processor, you have the Android operating system, so it's everything that you'd find in a regular computer but in a wearable form factor, and there is some wonderful opportunities to use that in the industrial space. Again, it runs native Android operating system. It's nice to be able to write in a language that you already understand and applications that you're already employing, and this device supports that. The other thing it does is it's connectable. We're talking about the wearable space. Many of these Bluetooth devices, instead of talking to the phone, can also talk to these glasses. So in the enterprise space, if you need a really good barcode reader, Bluetooth connected, they work. If you need to read sensors, Bluetooth connected, they work. Open, easy to play with. And from the perspective of how you use them, these things are standalone or they're connected to the internet. And in the SDK, you can write apps for it, but you can also, there's a bunch of function calls that will be available that will allow you to work with other computers and just get information and push information to the glasses with or without the cloud. So, applications. And partners like SAP and a pile of others are working with Vuzix to employ these devices today in real-world applications. We're working with Mataio, SAP, and Augmented together to build applications for reading sensors in the field. Rounds, working in warehouses. This application I'm going to show you coming up really quick shows a few of those kinds of things being done throughout this video. So what you'll see is a person in a warehouse and he's putting on a pair of glasses that are waveguide based. And with those glasses, he looks through them and he first picks out of the warehouse parts. Then he rolls that forward and has a problem with his fork truck. And then along the way, he's getting information about safety areas and hazards inside the plant. And then in the end, he finally delivers in record time. So here, we'll let that play.
is 6:47 a.m. Where are pick requests available?
Begin.
Incoming pick request. For customer 351, 22 items, please confirm.
Confirmed.
Showing me the pick list. Go to aisle 17, shop 3.
Show item 1.
The size for item 1 is 30 by 25 by 5 and the weight of 0.5 kilogram. It's non-fragile. Pick 2.
Two okay. One okay.
Pick request confirmed. Pick 3. Three, okay. Order complete. Warning, forklift malfunction detected. Proceed to maintenance area.
Okay.
Hey, how are you doing? Be sure to set it to DC. What's the voltage?
Okay. Reading 12.3, 11.9.
Just put both tubes together and you should be fine.
Warning, forklift nearby. Order complete.
Pause.
So the reason why that can happen is because these things have been designed with the optical systems aligned in an appropriate fashion so that you can put augmented information that's related to the real world in a see-through fashion, and the processing power and everything is built into the glasses local. So the processing speed can be there. And I'm going to give you an example of how that works. Unfortunately, unless you're wearing these glasses, you're not going to get a feel for the processing speed, because the way the video comes off of this with this serial link that we're using is a little slow. In fact, it's quite slow. You'll see it work. I brought with me a warehouse. Sorry, it was hard to bring a real warehouse in. And this is really just a simple demo that kind of gives you a feel for how this thing might operate. The idea here is, this is aisle 17, and when you look at this card, it'll recognize the warehouse, and if this was a real warehouse, it would do that, along with some Wi-Fi positioning information inside the warehouse and some other sensor technologies. And then it gets assist from the camera. So the user's using the glasses, he's saying, okay, where do I need to be? And there's several modes of operation. One is overlay mode, where the fields of view of this and the camera together, the way they're built, actually overlay the same field of view that your eye, your vision system sees. So when you're looking through this thing, everything's aligned, and I'm seeing an augmented slice of information in the one eye. The other way is it just runs full screen mode. And I'm going to show you full screen mode here. So it'll recognize the warehouse. It'll tell you that, hey, this aisle 17 is where there's fork truck traffic. Be careful. You're supposed to be wearing a safety helmet here. And then it'll identify the left-hand side, over here, right-hand side, sorry, of where you're supposed to do the pick. And then when you get close enough to pick the boxes, it picks out the barcodes and says, hey, we're going to pick these 3 pieces. So it's a really simple sort of walkthrough to make that happen. And I'm hearing all of that support. We're going to pick 3 parts. We're going to go to aisle 17. Be careful of the fork trucks. Unfortunately, that audio doesn't come through, so I'll narrate that as I go through this. So let's see here. And this is where it gets tricky. Okay. So that screen you're seeing right there is the video screen that I look at when I put the glasses on. So out in front of me, I've got SAP Business Glasses, Start Settings. In here, it's crisp. It feels much higher resolution than that. This, unfortunately, is all part of the transmission system. But when you get a chance after, you can check this out if you'd like to for yourself. So I got to start the app up, and it's saying starting. And like I said, unfortunately, the frame rate's a little low, but as you can see, the camera's operational. When I look down here, it recognizes where I'm at, and it's saying, warning, I'm entering a secured area. You're supposed to be wearing a safety helmet. And at this point in time, it's saying, look, we got to go pick 3 parts. So when you look around, it identifies this left-hand side, this column as aisle 17. And when you get close enough to where you're picking from, you can see it recognizes the appropriate boxes, and it just goes through the picks. Now, normally, you'd pick up the box, the barcode would scan, and at that moment in time, it would be debiting that information from the warehouse. So when you had your staff go back in and do an inventory count, it actually matches the stuff that actually came into and out of the warehouse. So this is a tool that makes it so it becomes really easy to train people, and it's interactive with the database, so all this stuff happens in real time, and it keeps the database accurate. Let me go back to where we were. As you saw, that's one of a bunch of different applications that are happening around these smart glasses, and as I said, they're focused more on the enterprise space. Here's another example of a gate agent application that we're doing with another partner out of Europe, Sita, and I'll just let him talk you through it.
So wearable computing is a computer-powered device that can be worn by a user, like this, which will give you access to a heads-up display that will give you a lot of information. It can also be, smartwatch. It can also be fabrics now with some interactions. So a smart glass like that has all the features from a smartphone, but everything integrated into a smaller piece of equipment. And that smaller piece of equipment is, again, wearable and easy to use. Sita Lab initiated some research on the subject of wearable computing, and we've looked at different use cases and see how we could apply the use of wearable computing in our industry. The use case we've been working on is a gate agent use case where the gate agent will be wearing this wearable computing device, and when passengers are coming in for boarding, they would hand out their passport and their boarding pass, and then just by looking at it, it's scanned. So what happens here is that the passport gets scanned and also the boarding pass, and if there's a match between the name, then we get in the small display here a green light and the passenger is allowed boarding. So this is first generation technology, and the technology will keep on improving. We'll get better devices, and at Sita Lab we'll continue to conduct research. We'll look at different use cases, different scenarios where we can use wearable computing to improve airline and airport operations.
So it's really simple stuff, actually, in this case. But without the processing power local, it's difficult to do unless you just take a picture and wait for a response to come back. So real-time operation requires operating systems, the processing power, et cetera, inside the glasses in order to keep up with what the real-world expectations are for the user. It's kind of like touch screens. A touch screen works well because when you touch the screen and you do this, the graphics slide instantly. They're there and it's happening in real time. For AR to be effective in the end, that's the kind of experiences that need to happen. So it's great. The world's starting to adopt this technology. It's being used in enterprise kinds of applications. It's gotten small enough that you can actually wear it and not even look all that bad, quite frankly. But when does it become mainstream? If you look at this chart here, there's a few obvious things that you can see down in the left-hand corner, and I think that's where a lot of the head-mounted display technologies have been, and quite frankly, including some of the products that Vuzix makes. This has been a tough business. They're geeky, and it's really been tough to find a market, a place to use these kinds of devices. But as the world's been changing, the function part has been happening. And quite frankly, the look and feel of these devices has been improving significantly. So if you look down in the bottom right-hand corner, we're really starting to approach this side of the curve, or the chart here. It's great for the enterprise, but to get up into this side of the chart where it's really mass market, the technology has to disappear for the user. It's got to be sleek. You can't look like you're standing out for the mass market. I'm talking the big mass market, the everyday use case kind of applications. So the technology's got to get improved. It needs to disappear and look normal so that the average person, your grandmother walking down the street, the average person who doesn't like to stand out will put these things on. So the technology needs to figure out how to get to disappearance. So the question is, how do you get there, actually? We're still dealing with most of the conventional optics systems that have been in the marketplace for years. And I'm not trying to be disparaging here on any of these products. I think most of them are amazing products, quite frankly, especially when you consider how good they are compared to where we've been. But the fact of the matter is, if you want a big field of view, if you want to augment the space in front of you, you need optical systems that can supply the imagery that is large and gives you a large field of view. And to do that today with conventional optics, the optics grow. There's not a system out there that doesn't follow this law. It's physics. It's just the way it is. When you look through a window, if you want to have a big field of view, the window needs to be big. So the optics are a big problem today. And I get one of the biggest questions is, what's wrong with you guys, us included? Can't you just hire a decent industrial designer and make these things look good? And it's a fundamental problem. It is not possible. Well, you can make compromises in the solution, make small fields of view, squeeze it down, and end up with something that looks acceptable enough to use. I don't know if it's acceptable enough to get into the really big mass market, but it's a great start. If you look at these products right here, it's telling. The Oculus Rift, it's an amazing experience when you put it on. It's the biggest field of view of any of the products up here. And when I say field of view, just to make sure we're all on the same page, a human being's got a field of view like this. He can see everything in this room. All of you down there, I can just bend my eyes and you're there. That's a big field of view, 120, 180. Peripheral vision, it goes even further. This guy gives you an experience of like somewhere between 98 and 100 and something degree field of view. So when you put it on, you get this kind of like looking in this room experience. The problem is, look how big it is. I mean, it's big because you need great big optics to supply that experience. As you go down this row, the fields of view get smaller. And as you go down this row, the fields of view get smaller. The smaller the field of view, current optics can make smaller devices, but they don't give you the experiences that everybody's looking for in the long run, which is augmenting the world around you. That is a major step change, and it's a difficult one to get over. Current optics have limits, and the reason why is they're windows that you look into that are boxes that bend the light with either refractive or reflective technology. So what happens here is this is a little micro display, the thing that's about the size of my finger, as I discussed. And then down underneath here is a big chunk of plastic. The window that you look through inside that plastic will determine it and the amount of material you have and how you designed it, the size of the field of view. If you want a big field of view, this gets bigger and that gets bigger. So you can see these are great big boxes. They bend light conventionally. It's a challenge, beyond a challenge, to make that look like normal conventional glasses. So a new technology is needed, and people have been working on wave-guided optics to help make this happen. And I should have brought a sample with me. But the idea is, it's not simple, but the idea does make for a simple optic in the end. If you look at these guys right here, they're looking like conventional glasses. And the way you make that happen is, instead of bending the light through these guys, you make a little tiny display engine in the temple. And then it determines the size of the field of view of the engine, of the final image that you look at. And the waveguide takes the small field of view, the small engine, and makes a great big optic in front of your eye, a window that you look through. So it expands this little tiny lens into this great big thing, but it's through a nice flat assembly. This is the kind of technology that's needed to get from these big, bulky kinds of devices to big fields of view, amazing experiences. You put them on and you step inside the image and you can interact with the world. And that's really what people want to have happen. The nice thing in about 1997 when we said, let's work with the defense marketplaces, they've been helping us develop this technology. Well, we've been helping them get to where they need to be through our technology. This is purpose-built technology Vuzix has been working on that's designed for the wearable display industry to make fashion-based glasses. I won't go into a lot of details, but in the end, when you take those waveguides and put them in a pair of glasses, you end up with something that looks like this. And this has not gone through an industrial design firm. This model is true to form with the size of the optics. It has quarter HD display engines built into it. Everything's one-to-one. If you handed the guts of this to a company like Oakley, you would end up with a really cool-looking pair of glasses. And you'd have the fields of view that you're looking for. This one has about a 35-degree field of view. And we're working with DARPA right now to make one with a 70-degree field of view. So the optical systems are finally coming around to make these things look like the vision that we're all looking for. But you need software to make it work too. I'm skipping over a lot of other details to make these things work. The sensors, there's just a bunch of stuff, as you might imagine, that's inside these boxes. But the ones I'm sharing with you are probably the more critical ones. So you need software. And it's partners like Mateo that are helping make that happen. Vuzix and Mateo work together. We've been working together for a couple of years now. They've built the first augmented reality software development kit designed for wearable computing. It runs out of the box with Vuzix's devices. The way these glasses know where you're looking in space is through this software. It's a challenging problem to look out with a camera, measure the space in front of you, and then put objects in it where they belong in a 3D space, and do that in real time. It's a very difficult issue. It's one of the hurdles that needs to get over. And again, if you work with Vuzix's products, you can easily employ this technology from Mateo Corporation to do exactly that. Oh, let me go back for a minute. And I'm going to show you a video here that shows the next gen of this, which is done in hardware. The goal here is always on, always augmented. So you put the glasses on, it's running with a low power hardware solution that's using the cameras to scan the world and come up with a measurement for how far things are away, and then use software on top of that to put stuff in the real world.
Ever since I started my professional career, my goal was to provide a seamless AI experience that feels natural to the end user. We know it takes great hardware and great software to achieve this. Until now, Mateo has been well known for best-in-class augmented reality software. Today, Mateo introduces a new piece of hardware, the first augmented reality processing unit, which will run and power the next generation of AR smartphones.
The talented teams at ST Ericsson and Mateo have been working together now for several years to bring augmented reality to every smartphone. With the use of Mateo's AR engine, ST Ericsson is taking augmented reality applications to a whole new level of performance and energy efficiency.
The AI engine drastically reduces power consumption, making all-day augmented reality experiences possible. Imagine walking down the street with your AR glasses, where the camera is scanning your surrounding constantly. The future of AR will be always on, always augmented.
These are amazing pieces of technology that just even 3 or 4 years ago were practically impossible to do. Taking these optics, taking the small CPUs, taking the tracking software that's available today. This tech is being explosive and making amazing changes in what's possible with a wearable display today. You will see over the next couple years the kinds of visions I believe that people have always wanted and dreamt about with this technology to be, and it's finally coming. And this last video I want to show you is an example of what it might be like in a future where this technology was all employed and being used in the real world. It's an interesting video because there's actually a controversial component to it when it comes to personal privacy and the like. We could talk about it, but from my perspective, if people opt in to these kinds of things, it works great. And if they don't opt in, then it should be stuff that doesn't get turned on. But I mean, these are some of the debates that are going on around this whole concept of wearable cameras that know who you are, or at least could find out by doing web searches and the like. In any event, this is an amazing video. Oh, I'm sorry. Infinity AR is also a company that is doing some stuff with Vuzix Corporation, and these guys have an amazing vision for the future, and it's the technology that Vuzix is building and companies like Matteo that are going to enable it.
You're about to embark on the most wonderful experience of your life. I will not explain at this moment how and why it works. I don't have the time. Just that.
Unlock doors. Directions to Amsterdam Billiards, New York City.
What can I get you?
I'll have a whiskey neat.
Okay. Here you go.
You don't happen to be a Gemini, do you?
Wait, how did you know that?
Just a hunch.
Oh, you had a hunch. Okay.
So listen, I gotta run, but we should get together later.
Sure. Sounds good.
Send friend request. Hi, nothing much, just chilling at my house. Any interest in joining? How are you?
I'm good, how are you? So good to see you.
Good to see you too. Can I offer you a glass of Sauvignon Blanc?
Yeah, that's my favorite.
And not to be too cliche, because Vuzix does use this term a lot, I think a lot of people do, but smart glasses, augmented reality, the technology that's coming, the future's so bright, you gotta wear shades. Thank you.